traditionally been on the exam. Right, this question here, next one, 2024 deferred paper. Lads are telling me there that for January 2006, this is on page 352 in your exam papers. It could, of course, be on a different page in exam papers in the future. So, Susan is playing a game of darts called Hit the Bull. In this game, a player throws 3 darts at the bullseye in the centre of the dartboard. Probability Susan hits a bullseye with a single dart is 0.2. So the probability of a single dart hitting the bullseye is independent of the outcome of the previous throw. Find the probability Susan does not hit the bullseye on a single throw. So she hits it. Hit is 0.2. So it looks like miss is going to be 1 minus 0.2. So probability of a miss is going to be, it's 0.8, yeah? No? Yeah? Comprende? Find the probability that Susan hits the bullseye with her first dart and does not hit the bullseye with the other 2 darts. So, dart 1, this is here me setting it up English. Dart 2, love, no problem when you do this. Dart 3. So, the first one, we want to hit. And she does not hit it then with the other 2. So, miss. And she misses. And we're going to get the word and in there because we're saying probability that she hits with the first dart and she misses with the second and she misses with the third. So we know hit there is 0.2 and means multiply 0.2 and with 0.8. So I don't know, you tell me what the answer there is. That something like 3.2? No, 0.32. 0.128. Sorry, way off there. Okay, that's the answer. Probability done. Next question. Next question there. So, apologies, sorry, I had a board frozen, I keep forgetting to unfreeze it. So, hopefully that's okay there. Probably hit the first one and miss the second and miss with the third, and you just add the probabilities and you multiply them together. It's a bit like the fundamental principle of counting, really, in disguise. Successive events, this would be called. One event is done in the successive event. Now, one thing I'm going to mention while some people are catching up there. There was a question about a basketball player, and I'm going to liken it to this question. There was a question about a basketball player, and how, lads, can you hear this one? There was a question about a basketball player, and a basketball player, again, he'd a chance of getting one basket was 0.9 or something, and obviously if he misses 0.1, and then what could affect his future throws? And the answer was like his previous throw. Well, it doesn't mention that here, but it could affect your confidence, couldn't it? The way you stand, the way you go, maybe you shuffle a bit. But look, we're taking all things into consideration here, I suppose. So, another expected value question here again, where, you know, the probability that she scores 150 from the 3 darts is 0.008. Very, very slim chance. Now, it's a bit like, you know, when your man says, you know, to your one in Dumb and Dumber, do you know, do I have a chance? And she says, yeah, about 1 in a million. He goes, so I have a chance. You know, like, yeah, you could argue that. So again, chance of scoring 100 with out of the 3 darts, so that means you'd have to hit 2 bulls. Again, slim chance there, 0.096. The chance of getting 1 bull from 3 darts. Now we're talking. Now again, this is out of, like, it's a bit, that's kind of a 3 in 10 chance or a 30% chance, isn't it? That's quite high of getting a bull with 3 darts. She must be decent. I know that if I had 3 darts, mine would be lower than that. I'd be down at about 10%. And the chance of getting 0 now, she's a high chance of getting 0. So you multiply them all together individually, and then you add them together, and there's your expected value calculated. Right? So, again for me here, E for expected values. This is expected score. Put down X there if you want. Whatever is equal to the sum of the event multiplied by its probability. So probability of each score. So the score by the probability of each score. Sorry with that writing there. So we're going to get 150. That's 3 bulls. Gee, that's really low. Plus chance of getting 100. That's 2 bulls. It's a really low score again by 100. Plus the chance of getting 50, 1 bull, it's 0.384, so that's about a 30% chance of getting 1 bull. And of course there, that's going to be 0 at the end, 0 by 0.512. So, can someone please tell me the answer to that? 30. 30.512. It's not just 30, no?
It's just 30.
It's just 30. Now, what does that mean? That means that her average score from 3 darts, her expected score from 3 darts is 30. Yeah, you're saying, how the hell can she get an expected score of 30? If she hits one ball, she gets 50. Well, again, this is about over time. It's about over statistics. Maybe if she throws 6 darts, her average, or double that up to 60, to 90, to 120. This is like her expected score from 3 darts, but of course she might throw 120 darts, and then whatever that would equate to in that. So you just got to factor that kind of stuff in. Right, done.